Okay, in this video we are going to prove a simple relationship between a graph and its dual graph. So the statement reads as follows: the edge E is a loop in G, okay, if and only if E star, the corresponding edge E star in the dual graph is a cut edge in G dash. Okay, so before proving this thing, this statement, let's look at an example. Okay, so the statement reads: if E is a loop in G, then E star is a cut edge in the dual graph, and similarly if E star is a cut edge in the dual graph, then E is a loop in the graph G. Okay, so before proving this statement, let's look at an example. So let's consider this example. Okay, this example, so consider this graph G. So this red graph is our graph G and this blue graph is our dual graph. So here we can see that this red graph, it has this loop. Okay, and let's call this edge E. Okay, and here we can see that this corresponds to E star. Okay, so let me use a different color. Okay, so here this corresponds to this edge, and let me label that edge E star. Okay, so here we can very easily see from this figure that, okay, this G, it has this loop, and if we look at the dual graph of this G, which is the blue graph, okay, this edge corresponds to E star there. Okay, and similarly we can also see that if you start with this blue graph and take the dual, okay, you get this red graph, and we can very easily see that this E star will turn into a self loop here. Okay, so from this example we can see that the statement seems to be true, and let's go and prove this general statement. So the edge E is a loop in G if and only if E star is a cut edge in G star. So here again we can see that the statement is in if and only if form. So we have to prove two directions. So first direction is okay, if E is a loop in G, then E star is a cut edge in G star. That is one direction, and the other direction is if E star is a cut edge in G star, then E is a loop in G. Okay, so let's go and prove both directions. Okay, so let's prove this direction first. So that direction reads as follows: okay, if E is a loop in G, then E star is a cut edge in G star. Okay, so let's prove that direction. Okay, so we assume that E is a loop in G, and we will prove that the corresponding edge E star in G star is a cut edge. Okay, so cut edge means if you delete that edge, the graph will become disconnected. Okay, so there won't be a path between the vertices joining this particular edge E star. Okay, so let's go and prove this statement. So let the edge, okay, let the edge E be a loop in a plane graph. Okay, in a plane graph G. Okay, so here we can very easily see that, okay, if E is a loop in the plane graph, so it is going to share a common boundary between two regions in the graph G. Okay, so let E be a loop in a plane graph G. Okay, then what is going to happen is that we can very easily see that E is on the common boundary of two regions. Okay, so let's say that E is a common boundary of two regions F and, okay, for example something like this. Okay, so let's consider this loop, okay, which is labeled E, and it is on a common boundary of these two regions G and F. Okay, so let's see what is going to happen. So if E is a loop on a in a plane graph G, okay, E is on the common boundary of two regions. Okay, let's say that it's a common boundary of F and G. Okay, so we can see from the definition of G star. Okay, so from the definition of G star, okay, E star is the only path from F star to G star in capital G star. Okay, so that's what we can see here, right? Okay, so if you look at this dual graph, okay, we can see that the only path between this F star and G star is only through this edge E star. Okay, that is by the definition of the dual of a graph G. Okay, so that says from the definition of G star, E star is the only path from F star to G star in G star. That says if you delete this edge E star, then these two vertices are not reachable, mutually reachable from each other. Okay, and that says E star is a cut edge. Okay, okay, so thus this E star is a cut edge in G star. Okay, and that's the proof for this direction. Okay, so we can very easily see that if E is a loop in a plane graph, it is on a common boundary of two regions, say F and G. So from the definition of the dual graph G star, E star is the only path from F star to G star in capital G star. Okay, so that says if you delete E star, then there is no way to reach F star from G star and from G star from or vice versa. Okay, and that says E star is a cut edge in G dash. Okay, so that proves this direction. So that says if E is a loop in G, then E star is a cut edge in G star. Okay, so let's go and prove the other direction. If E star is a cut edge in G star, then E is a loop in G. Okay, so let's go and prove that direction. Okay, so let's prove this direction. Okay, that direction reads as follows. Okay, if E star is a cut edge in G star, then E is a loop in G. Okay, so let E star be a cut edge, okay, cut edge in G star, and let this edge E star, it joins vertices, F star and G star. Okay, something similar to this thing. Okay, so we are looking at this dual graph, and we can see that this E star is a cut edge. If you delete this E star, then the graph will become disconnected. Okay, and let's see what is going to happen in our dual graph. Okay, so let E star joins vertices F star and G star. Okay, thus since this E star is a cut edge, E star is the only path in G star from F star to G star. Okay, thus E star is the only path in G star from this vertex F star to G star. Okay, so we can very easily see from this particular example. Okay, and again from the definition of the dual graph G star, it implies that the edge E in the graph G, okay, it is going to be completely enclosed on the regions, okay, either F or G. Okay, and that's what we see here, right? So that we can see that, okay, this particular edge in the dual graph, okay, in this case dual graph, this graph G and dual graph is G star. So we can see that in our graph G, okay, that edge is going to enclose either G or F. Okay, and that's what we want to prove there, right? If we then okay, that E is going to be a loop. It is either going to enclose this F or G. Okay, so very easily we can see that from the definition of G star. Okay, it implies that the edge, okay, E in G, okay, it completely encloses. Okay, it completely encloses one of the regions. F or G, okay, corresponding to this F star and G star in our dual graph G. Okay, and that says, okay, E is a loop in graph G. Okay, and that's the proof. Okay, so we proved this direction as well. So we are able to prove both the direction. Okay, if E is a loop in G, then E star is a cut edge in G star, so this direction and the other direction. If E star is a cut edge in G star, then E is a loop in G, and hence the theorem.